All right. So the first question says that which one of the reaction of hydrochloric acid below is a redox reaction? So to be a redox reaction, I mean, all the reactions here, A, B, C, D, all the reactions, it involves the electron transfer. All right. So electron is transferred from each, I mean, one to another. I don't know. I mean, you have to see first from where to where it is going, but it is going from one to another species or element or ions. But all of them are not redox reaction. Not redox reaction. Why? Because the oxidation state or the charge, the difference is not changing for the product they are producing than that in the reactant state. So if the changes are no change in the oxidation state, no net changes in the oxidation state, then it is not a redox reaction. For this A, we see that HCl and sodium sulfide, H is positive 1 because chloride is more electronegative and it is negative 1. Sodium is positive 1, should be positive 1 because sulfur is negative 2. Although sulfur has a different oxidation state, but most prevalent is negative 2. Okay, so in this case, we see here on this side that hydrogen chloride produces hydrogen sulfide gas, and still hydrogen is positive 1 and sulfur is negative 2. And sodium is positive 1, chloride is negative 1. So the oxidation state for this reactant has not changed. It's still the same thing what they were in this reactant, the same oxidation state in the product side. So it does not change at all. So it is not a redox reaction. So which one is only the redox reaction of the hydrochloric acid that has been changing? All right. From there, we see that B, hydrogen positive 1, chloride negative 1, iron is 0 here, right? And hydrogen was positive 1, it becomes 0. And iron was 0, it becomes positive 2, right? So hydrogen was positive 1, it becomes 0. That means it gained an electron. Right, it gained 1 electron. That's since electron is negative, so it neutralizes the positive charge of hydrogen and it becomes hydrogen 0. So that is how hydrogen become reduced. However, iron from here to here, it changes to positive 2. That means is lost 2 electrons, and that is how it becomes oxidized. So this is the oxidation reduction. Question number, option B is oxidation reduction. The C and D, from this logic, if you go, you'll see there is no changes, net changes in their oxidation state. And question number 2 is the same thing, almost similar thing that we see, that potassium oxide, was 0. Here it is negative, positive 1, sorry, it is positive 1. Potassium is always positive 1 because it is a group 1, right, element. And oxygen was 0 here as well. It is not a 0, it is a negative 2, sorry, it is negative 2 already. So it is a redox reaction. The question is asking which one is not. So when you try to, there will be this type of question in your midterm test, right? So please read the question first. Read the question first. Otherwise, you just tick it. It's wrong, then you lost the mark. So in this way, if we go and deduce all these 3 options, okay, so we will see that lithium oxide here, lithium is positive 1 and positive 1 on this side, oxygen is negative 2 on this side, and lithium is still positive 1 on this side, and hydrogen is positive 1 as well, oxygen is negative 2. on this side. So the net oxidation state is not changing. That means it is not a redox reaction. And the rest.
Teacher, at 2A, there's something wrong with the equation. There's only 1K for 2Ks and 2 O's for 1.
Yeah. It should be 2 here, right? If it is 2 here, then hold on. Yeah, it's 2 here. Then no, it should be 4 here. It should be 4 here. Then here it is 2. All right. So 4K plus O2, that is a gas. So you cannot just write O. It has to be O2. Then we can produce 2K2O. And this how the reaction will be balanced. So 4K, that means 2 times 2, 4 potassium, and 2 atoms of oxygen is here. So 2 atoms of oxygen is there too. All right. So thank you for this pointing out. Okay. So question number 3. Any redox reaction, the substance that undergoes a reduction, right? What will happen? A reduction means gaining of electron. Oil rig, always remember oil rig. Whatever, just remember oil rig. Oxidation is losing, reduction is gaining. So here it says that that undergoes a reduction. That means it will be, electron will be gained. For sure, the electron will be gained. That is the first thing. But what will happen to the oxidation number? If the electron is gained, and the oxidation number will decrease, right? Because oxidation, let's say X amount, X, and the oxidation state is, let's say 5. So if it's gained the electron, it is reducing. And the more electron it gains, even if it gains 10 electrons, it will get, it will negative, it will go to -5. That means it is reducing. +5 means increase, -5 means reduce. So it is even from 0 to -5, that means it is losing or reducing. So that gain electron and decrease in oxidation number. So that is the answer. Question number 4. Oxidation. This is just the opposite thing, that oxidation is losing of electron. So electron will be lost. So these two are not correct. We cannot, no need to consider these two. So among these two things, the loss of electron and the increase in oxidation number. All right. Okay. So increase in oxidation number. So that means, and another one is loss of electron and decrease in oxidation number. So electron is losing and oxidation number is increased to positive number. Okay. So number 5, question number 5. So this is the correct answer. Okay. Number 3, C. Question number 5. What is the oxidation number of the electrons, elements in perchloric acid? Perchloric acid. What is the total charge of perchloric acid? Can anyone tell me what is the total charge for perchloric acid? The total charge of perchloric acid is 0 because there is no charge, right? There is no positive, no negative, it's total 0. So since it is 0, then hydrogen will be +1, right? Oxygen is -2 because oxygen is more electronegative than chlorine. Yesterday we talked about it, and there are 4. Hydrogen is +1, oxygen is -2, and 2 negative times 4, right? And it's all together is 0. So there is no other choice but chlorine must be +7, right? And only then the total equation becomes 0. That means What is it? Positive 1, positive 7, negative 2. Okay. And the vanadium pentoxide, vanadium oxide, vanadium tetroxide, there are two different vanadium, and because of this, we have seen in the lecture that they are that the color changes. The color becomes different. The solution color of the solution or the solid salt of this vanadium compounds is different due to this oxidation state, electron differences, and also because another thing that I want to tell you that just because of this charge of the vanadium, one is very toxic, I mean lethal, another one is life-saving. So the oxidation state is very important, that is why. Is there any question? Let me check. Well, there is only one K for K2. Okay, yeah, I solved already. So for this, I think you can solve this question. Question number 7, the equation for a reaction that occurs during the extraction of iron from the iron ore is ferric oxide or iron 3 oxide, and carbon monoxide, okay, and it is producing iron 0. That means it gains the electron, isn't it? It was positive here. It is negative 6. Negative 6. It is positive 3 times 2, 6. So it's positive 3, it's negative 2. Oxygen is negative 2. So from this positive 3, this iron becomes 0. And that is why we are saying that it becomes reduced, because it's the reduction reaction. And due to this gaining of electron, iron become reduced by gaining the electron. So it says that during the reaction, the oxidation of iron changes from positive. Oh, okay, I already said the answer is already given, right? From this. So what is the answer for this? From positive 3 to 0 for iron, and carbon monoxide is a reductant, yeah, because carbon monoxide is helping it to reduce. So this is the reductant. Question number 8. I prepared one Mentimeter for you. Let me find it. Where is it? Later I'll give you the code so that you can try. The reaction between iron, question number 8, right? Question number 8. The reaction between iron and nickel 2 sulfate may be represented by the ionic equation nickel 2 iron and then nickel and so here it is very obvious. We can see it very clearly that from nickel 2 plus it is becoming 0, and that is how it is become reduced to nickel element, and from elemental iron it becomes ionic iron. That means it was 0 here, losing the electron. That means it's become oxidized and gained. So whichever is what is the correct answer for this, whatever is it, you can just tick. Consider let me tick it for you guys. It is nickel, yeah, question number 8 is the correct answer. Consider the following reaction, all right? Consider the following reaction, and then you see that manganese and lead. So manganese 2, lead is the same thing. Which one of the statement is correct? So a manganese metal is the oxidant. Is it? Manganese metal is the oxidant because manganese itself become oxidized, right? So it cannot be an oxidant, but okay, manganese cannot be an oxidant because it itself become oxidized. So it's the reductant, yeah, that's true. And another thing is electrons have been transferred from manganese metal to lead ion. That is true because lead needed the 2 electrons to become 0 charge, and this 2 electron was provided by manganese, and that is how manganese became 2 plus. So this is correct answer. Which one of the following half reaction is correctly balanced? Okay, so chlorine, and it is taking 1 electron and then it becomes chlorine ion, right? Chlorine ion. So this is not the answer. I think the answer is already given, right, for you guys here. So you know the answer already, but the explanation for this, that chlorine is taking electron and becomes chloride ion, but here is 1 electron. 1 electron is shown. There are 2 chloride atoms here in the molecule. So what happens to the another 1 chloride? So it is not balanced. At least it should have 2 electron in this way, and there should be 2 here, so that it would be balanced. How about aluminium and that is what is happening here for B? Oxidation or reduction? This is a reduction, right? Because aluminium 3 plus changes to aluminium 0, right? So it is taking the electron. So when it is taking the electron, that means 3 electrons should be on this side, right? 3 electrons should be in this position, that I mean a reactant position, because it is not producing electron, rather it is taking that electron. So we have to provide the electron in the reactant side, not on the product side. Product side means that electron has been produced. That means in this case it would be true if aluminium, if we would write aluminium 6 plus, then it would be true. But so it is not correct as well. Question, I mean option number C, that is iron 3 plus and it is becoming iron 2 plus, and it is true because from 3 to it is changes to 2, and to change to 2 it needs only 1 electron. That's it. So it is correct. Question, option number D is nitric oxide and hydrogen. It's producing nitrogen dioxide. This cannot, sorry. So it is making nitrogen dioxide and water, right? So in this case, what is missing is this nitrate. This nitrate ion is lost this charge and 1 oxygen. So this oxygen, 1 oxygen can produce only 1 water molecule, and then this water molecule has been produced. So this is good. This is very good. So oxygen and nitrogen dioxide, this is all balanced. Only the thing is the charge. There are 2 charge here. Hydrogen, there has 2 positive charge. That means each hydrogen will have 1 positive charge. So in this case, I would need 1 more electron on this side. I have 1 electron from this nitrate ion to neutralize the hydrogen charge, right? But there is another charge still staying. I still have another charge to neutralize because there are 2 hydrogen atom or 2 hydrogen ion. Okay, so 1 of this ion, I mean hydrogen ion, has been neutralized by this charge of the nitrate that is on the nitrate. Trying too much. Okay, so 1 of this hydrogen is neutralized by this negative charge, and I would need another electron. I would need another electron to neutralize the leftover hydrogen charge or the rest of the. So this electron should have been on this reactant side, not on the product side. All right. So that is why it is not the correct answer. So be careful this type. I mean, when you are MCQ type question, you read it through first nicely, carefully. Question number 11. Which statement about water in the following half reaction is correct? What is happening here? The water, there are two molecules of water, and then they're taking two electrons and producing hydrogen and hydroxyl, right? So which was water has acted as a reductant only, is it? Because here we see that hydrogen is positive 1, it is negative 2. So here hydrogen becomes 0, and the hydroxyl for this oxygen, here it becomes, what will be the oxygen? Let me check. Hydrogen is positive 1, right? Positive 1, and then there is negative 1, so it is X. So still oxygen is 0, sorry, negative 2. So negative 2, and that is why the hydrogen from positive 1 to 0, it becomes reduced. For the first water, the first option, water is reduced to here, go to here, so it becomes reduced. So that is, it is not a reductant. It cannot be reductant because it is itself reduced. Hydrogen, water has acted as an oxidant only. Okay, that is quite fair because it becomes reduced, so it oxidized itself somehow. All right. So this is the correct answer for B. And has an oxidation. Water has acted both as an oxidant and a base. It is an oxidant and not necessarily it is acting as a base, because this hydroxyl molecule, we do not know what is here, right? If it has to be a base, it has to act with a strong acid. It has to act, with a strong acid, so that only it will be as a base. So, but we do not know what is here and how it becoming ionized. So we cannot, with confidence say that, okay, it is, yeah, sometimes it works as a base, we know, but in this case, there is no other information, so we cannot say. It's self-ionized. We do not know also it's self-ionized or in presence of some acid environment, it becomes self-ionized. So this is also not very clear, so no need to claim that thing as well. Right. So question number 12, it says that which of the following reactions in the underlying species acting as a reductant? So for this case, we see the reductant means it should oxidize itself, but it will reduce other, right? So which one is having oxidation? Oxidation is losing of electron. Here copper was positive 2, positive 2, oh my goodness, positive 2, it becomes 0 here. That means it did not lose, rather it gained the electron. And oxygen was 0 here, but in this case it becomes negative 2, also negative 2, right? So that it gained the electron in this case for oxygen, gained the electron in this case. So since it gained the electron, it is it is undergoing a reduction, so it is an oxidant since it is undergoing reduction. So same thing. And chromium, for chromium, if you try and see, it will be the same thing. For sulfur dioxide, rather you see that sulfur dioxide here, it is no charge. That means sulfur will have positive 4 oxidation state, where oxygen is negative oxidation state. But in this case, for on the product side, we see that sulfur from positive 4, it becomes positive 6, right? it becomes positive 6, so that it is losing, and it is oxidation happening, so it is a reductant itself. Question number, so the answer is D. Question number 13. Vitamin C or ascorbic acid, C6H8 and O6. This is ascorbic acid, that the vitamin C that we can get from the citrus fruit, lemon or this type, and other fruits as well, and also in the tablet form supplement that we take. So it is an antioxidant, whatever you call it. To determine the percentage by mass of vitamin C in a tablet, a student weighed one tablet into a conical flask and then crushed it in deionized water. That means we took one tablet and then we grind it, make the powder by using some kind of mortar and pestle type thing, and then I dissolve it in the water. The vitamin C was then titrated against iodine solution of concentration of 0.1 molar. So iodine solution, the concentration is given, right? And I think we will get the volume later on to find the number of moles as well. The equation for the reaction goes in this way, all right? It goes in that way. So given the titer was 27.4 milliliter and the mass of the tablet was 1.335 gram, what is the percentage of vitamin C in the tablet? So you see that the tablet was taken was 1335 gram, and all of it is not vitamin C. There are, I think we talk about it, that this is the vitamin C, and in the tablet it is solid form. There are so many things, starch, binder, blah, blah thing, and only a small percentage is a vitamin C should be. So how much, if it is the reaction happen in this way, and titration afterwards we add the starch, starch, and then we see that how it from green to blue it changes. So titration endpoint we find 27 milliliter, right? So what is the percentage by mass? One thing is, I mean, a helpful thing actually, that 1:1 reaction. So that means one vitamin C, one iodine is reacting. So if we know the number of moles of iodine, so we can find the number of moles of vitamin C as well. And vitamin C, from the formula of vitamin C, we can find the molar mass of vitamin C. That means 12 times 6, right? The molar mass will be 12 times 6, because 6 carbon, 12.01 actually, to be very precise, but I'm just rounding off. And hydrogen is 8 times 1, because there are 8 hydrogen atoms, and there are 6 oxygen, and oxygen are 16. So 6 oxygen. So in this way, we can find the molar mass of ascorbic acid or vitamin C. From here, we can find the number of mass. So you have done it many, many times. From there, you can find the percentage. In the end, we find is 58.5% of this. The concentration of hydrogen peroxide in an antiseptic solution was determined by titration with potassium permanganate solution, 0.2 molar potassium permanganate solution. 20 milliliter of the permanganate solution was diluted to 250. That means 12.5 times dilution happened here. And 20 milliliter of the diluted solution was then acidified and titrated. Acidified because this reaction is happening in the acidic medium, or because of this redox reaction, it needs some hydrogen ion to produce the water molecule from this oxygen that is liberated from here. So that is why acidic in the acidic medium, it has to be in the acidic medium. And an average of 18.95 milliliter was required. So from that number of moles and the concentration, the milliliter volume, we find the number of moles. And here another good thing here that the hydrogen peroxide and this reaction is happening to 2:5, manganese tetroxide, manganate ion, okay, and hydrogen peroxide is happening 5:2 reaction. From there we can find that how much of the hydrogen peroxide was there, how much I needed it, so how many moles of hydrogen peroxide was there, and we can find the concentration in that solution in this 250 or 20 milliliter. Okay, so question number 15, the same thing, sulfur dioxide was in a wine and is an antioxidant. I don't know how the antioxidants, there are so many researchers says that it has it has linked to the cardiovascular problem. Some says that no, it is good. I don't know where to stand on doing this. Okay, so slowing the oxidation of the ethanol to ethanoic acid, sulfur dioxide is an antioxidant, so that it does not allow the oxygen from the ambient air to go into that wine and then convert it from ethanol to ethanoic acid. It stops that. To determine the sulfur dioxide content in the ethanol, another type of titration was done, and iodine solution was used and indicator. So from there also it found that this is concentration in number of moles. What is the same way we will find it is 2:1 reaction from there, and sorry, 1:1 reaction, sorry, not this one, not this one, this 1:1 reaction, so that if we find the number of moles of iodine, we will find the number of moles of sulfur dioxide in the sample as well. All right, let me go and search the Mentimeter. I have one question. By the way, by this time, do you have any question? Oh, there are quite many questions. What there was, sir, you can repeat again of question 6. Okay, I will. And Bernice, a reduction. Only I don't understand what question you are referring to. So if you give me a little bit of a hint, I can go again. No, I don't mind. Okay. I was answering the question. No, it's okay. Oh, thank you. I didn't see it, but let me go through the question number 6 once again. Tutorial question number 6. For you. Okay, Gabriel, question number 6. I didn't actually talk much about it. The transition metal vanadium exists in a range of different oxidation state. 2 vanadium species are vanadium oxide, 2 oxidation state, and vanadium tetroxide, that is 3 negative charge. The oxidation state of vanadium in these 2 species are respectively. So what is the oxidation state for this vanadium oxide? We can find it in the same way that we try to find out the unknown oxidation state. So it says that vanadium, so we just put vanadium as positive X, right? And okay, vanadium oxide, 2 positive charge. All right, so here we assign positive X to vanadium because obviously oxygen is more electronegative. than vanadium, and there is only one atom of oxygen. So -2, and it is equal to +2. Okay, it is equal to +2. So in this case, x is equal to 4, +4. So, all right. So in the same way, if we go and find the vanadium tetroxide, we will find this +5. So this is why +4 and +5 is the answer to the question. Okay, let me go to the Mentimeter. Okay, so go to the Mentimeter, and then Brian, which one? Explain which question? Okay. Going to question. Okay, the question here I was vanadium. It says that what is the two vanadium species are here? The oxidation state. What is the oxidation state of vanadium oxide and vanadium tetroxide? The oxidation state of vanadium whole ion is positive, right? 2. So for this case, vanadium oxide 2 positive charge. That means this 2 positive charge is on the whole ion, is both on vanadium and oxygen. So I don't know what is the oxidation state of this V or vanadium, all right? But I know that oxygen will have a -2 charge because oxygen is obviously more electronegative than vanadium. Oxygen, there is only two exceptions, hydrogen peroxide, oxygen difluoride, right? Other than that, everywhere oxygen has a -2 charge. So since there is only one oxygen atom, so it will be -2, and vanadium I do not know, but I know that it will be positive. So I consider this positive X, right? And oxygen will be -2. So positive, this, if we sum these two up, it should be +2 charge. All together, it will be this +2 charge, right? So this is the formula, or this is the way that we find out what is the oxidation state of any of the element in the compound or ion. So if we solve this problem or solve this equation, then X will become +4, right? X will become +4. And the same way, if we try and go find this VO4, right? So let's say X plus -2 times 4 times 4, because 4 oxygen atoms are there, and all together it will be -3. It will be altogether -3. This is the 3, -3, right? So this is the 3. Altogether it will be -3, and then the X is equal to +5. If we solve this equation, it will be altogether +5. So that is why question 6, the answer is +4 and +5. Is it okay now? Anyone has any other question? Question number 14. Okay, question number 14 is here. Yeah. So this is the same thing that we already have done for, what do you call it? Already have done for the lab reports that we are still doing it, I think. So it's very similar to that, right? It says that we have to find out the number of moles or concentration, right? The percentage, concentration percentage of hydrogen peroxide in the solution of a hydrogen peroxide is also used to antiseptic and cleaning agent because it's oxidizing agent. But in this case, probably it's different because magnesium tetroxide is a much more strong oxidizing agent. So it says that we have to find out what is the concentration of hydrogen peroxide in the solution, right? So magnesium tetroxide, and it was reacted together, and the reaction goes in this way. So in this case, we took 18.93 milliliter of potassium permanganate. This magnesium tetroxide is coming from potassium permanganate, KMnO4, right? KMnO4, from there it is coming as a potassium permanganate. So this manganate ion, we needed 18.93 milliliter, and the concentration was 0.02 molar of this manganate ion. Concentration was 0.02 molar for this manganate ion. So from there, we can find the number of moles, right? We just need to convert this into liter, and then 0.02 molar. Molar means moles per liter, and then we multiply with this volume, that is 0.0189 liter. So from there, liter gone, the number of moles remains. So from there we find the number of moles of potassium permanganate. That means number of moles is required this. And now we can find that how many moles of hydrogen peroxide is there. The only thing we need to consider is hydrogen peroxide is 5 moles of hydrogen peroxide is reacting with 2 moles of potassium permanganate, right? So the ratio is 5:2. If 2 moles, then I know that there will be 5 moles of hydrogen peroxide. So if this number of moles, then how many moles will be there? So 5/2 of, if we multiply this number of moles with 5/2, because 5:2 reaction, or if we put the units, is even easier, that 5 moles of hydrogen peroxide, right, H2O, and 2 moles of manganate, MnO4, okay, and this is also MnO4. So this MnO4 will be cancelled out, right, 5/2, so that the number of moles of hydrogen peroxide will only be staying here, and that is how we will find the concentration, number of moles of hydrogen peroxide in the solution. And after that, we can find out what is the number of moles in 250 milliliter, because if it is in 20 milliliter, this number of moles, what will be in 250 milliliters. And that is what is the undiluted solution, is the same thing. Or we can just multiply this one with this dilution factor. We'll find what is the concentration in the undiluted solution. So is that okay now? Question 14, the volume of average titer is equal to the volume of magnesium tetroxide permanganate. Volume of average titer is, that is is or that is equal to the volume of manganese. It should be the average titer because there is no other reading is given. So just consider this is the average one, all right? Okay, so now I am going to this Mentimeter. Have you all signed into the Mentimeter? I'm giving you the code. So please try to. I will not know who is saying what, but I will see the statistics only, that how many people said yes, no, something like that. So the code is, okay, let me write it. Then I go to the 9. Okay, so this is the code. Let's go and sure. So if you can see this slide on menti.com. Oh, I should give you the menti.com. Okay, sorry, forgot. menti.com. All right. So go and click. What do you think? Is oxidation or reduction or none or both? What happens for the oxygen atom in the H2O2, right? This is hydrogen peroxide. I cannot write in that way that we write because this Mentimeter does not allow me to write the subscript. So I could not. So that's what I'm saying, that H2O2, this is a hydrogen peroxide, is from the aqueous solution, it is becoming water, H2O, and oxygen gas. Thirty seconds left. I see quite many of you have voted. Ten seconds. No need sign in, Brian. Voting closed. 24 of total participants has okay, I give for those who has not voted, I give 10 seconds for you to vote. This is last chance. Please, oh, come on. Tanya Razua, this is, okay, so the code actually given here already. You see that you scroll up in this chat room just before 1, 2, 3 message, there was the code was given. Okay, so we have 25 students has voted. 12 has says oxidation, 4 said reduction, 5 says both, and 4 said none. Okay. Now the thing is, Okay, so now the thing is, why it is oxidation? Because we see that here it was -1, right? On the left, the oxygen atomic, sorry, the oxygen charge. Just give me 1 second. Need to reply. The oxygen, the status or oxidation state of oxygen is -1 here. It is getting -2 for H2O and 0 for oxygen, O2. So when from -1 is getting to -2, that means it is gaining electron and it is being reduced. That means reduction is happening here. However, here it is when it is becoming 0, it is oxidation is happening here and it is losing 1 electron. So this is oh no, I was okay, sorry, thank you. I will go to the Menti. You cannot see the Mentimeter result. I thought you were on the Mentimeter. Yeah, here. So sorry, I didn't know that you cannot see. Only you can vote. All right. Okay. So the thing is, from here, the oxygen highlighter here. I don't have any highlighter here, so cannot. Okay, so hydrogen peroxide on the left side, right here. The oxygen here on the left side, I was talking that it has a -1 oxidation state. It is becoming -2 oxidation state here, and here it becomes 0 oxidation state. So that means from when it is -1, it becomes -2. That means it is oxidation is happening and it is losing, it is reduction happening, it is gaining electron, because -1 to -2, it has to gain electron. And from when it becomes 0, oxygen here, oxidation state is 0, that means it is losing 1 electron and oxidation is happening. So that's it, that sometimes both the scenario can happen together. All right. So this is something like we have to, this is something like it's not very uncommon. It's rare, but it happens in this way, that oxidation reduction both can happen together at the same time for the same compound. Okay. So for this type of answer, the correct answer should be both. If you say that, okay, both means half, if I say oxidation, then I should give half. No, that is not such thing, okay? Okay, so sulfur dioxide, question number 1, that's the structured question or essay type question, sulfur dioxide. Here we see that nickel and sulfur dioxide is reacting together. Sulfur dioxide is production. There are many ways to produce the sulfur dioxide. And nickel is, from here we'll see that nickel oxidation is happening, and nickel, that is why it is producing 2 electrons. Okay, so it will produce nickel 2 plus, nickel 2 plus, and then there will be 2 electron produced. All right. Oh, okay, sorry, forgot again. Yeah, this one. So here nickel is producing 2 electrons, and that is why it is oxidation is happening, because it is oxidation state is increasing, right, from 0 to positive side. Or if it is let's say originally for one, what, let's say it's X or Y, okay, new Y compound, it was negative 6, and from here it becomes negative 4. It is also still the oxidation state is increasing from negative 6 is very low to higher than negative 6, that is negative. So oxidation will state. Sometimes I saw students sometimes become confused. So that's the thing, that oxidation means oxidation state will increase from lower to higher. So that is it. Oxidation happening, and reduction reaction, that is sulfuric acid and hydrogen. Okay, the sulfuric acid, H2SO4, all right, and then water, sorry, not water, hydrogen ion and electron, hydrogen ion and electron, right? So that, and there should be 2 electrons, so the sulfur dioxide and water can be produced. These 2 electrons are given, these two electrons are given from here, so that sulfur dioxide and water molecule are produced. Okay, so altogether we will see that this is, I don't need the coefficient is okay, 1:1, so I don't need to multiply or divide it by anything. I can just sum it up, overall reaction, I will get the same thing. Okay, so is the reaction, is this for this reaction, right? For this reaction, is it oxidation reduction reaction? No, but because there is no oxidation state changes in it. Manganese, I'm not going to tell, because I hope that you can find out what is the oxidation state of manganese now. And I don't see much to talk, because you already have done this thing before, and for 3 labs you have already done it. So the same thing, how much of the number of moles have to find out, and from that number of moles, the gram per mole, from that number of moles, the molecular weight or gram weight of that, and then percentage of it. So yeah, it should be, I hope that it is okay. And this is pretty much really what we are talking about so far. So is there any question now? Is there any question? Do you want me to go over anything? Or if you, all these questions, this type, this question, I consider that it is, you have done in the lab, in the report, so you are familiar with this. But if you have any question on it, or if you think that I should talk more, Q1B, why it is not redox reaction? Thank you. Okay, going there. Question 1. Redox reaction is not a redox reaction, because you see here zinc has positive 2 charge, right, on this side, positive 2 charge, and oxygen is negative 2, that means 6, 3 times 2, 6, and sulfur has positive 4 on this side. So altogether is 0, because it is not carrying any charge. On this side, zinc still has positive 2 charge, the same, right? Same, positive 2 charge, and sulfur is positive 4 as well, all right? and oxygen is -2. So there is no changes in their oxidation state. There is no changes, although the reaction is happening, but there is no changes in the oxidation state. So that means there is no oxidation reduction reaction is happening. Although electron is transferring, electron transfer happening from one to another one, but no net changes. If there is no net changes in the oxidation state, it is not a oxidation reduction reaction. So anyone else, any other question? Any other question? Anyone? Okay, explain again about the Menti question. All right, I'm going to the Menti question. Yeah. Okay, so let me share the screen. My Menti, this is the Menti, and I hope that you can see here. All right, so we see that here for this hydrogen peroxide, H2O, I don't know how to present. Screen. Okay, so here you see that high oxygen, what is the oxidation state for this? The oxidation state for this oxygen is -1, because hydrogen peroxide, we always know that hydrogen peroxide has, the oxygen has -1 for hydrogen peroxide, H2O2. This is one of the exception for oxygen, oxidation state of oxygen, hydrogen peroxide and OF2, difluorooxide. So difluorooxide, oxygen has a +2 charge, and hydrogen peroxide, oxygen has -1 charge. So that this oxygen will have -1 oxidation state. All right, it has a -1 oxidation state, which is going, decomposing, and then it producing water and oxygen gas. This water here is -2 charge. This oxygen has -2 charge, and this oxygen, however, has 0 charge, because this is a elemental, a gas, right? This is a gas, oxygen molecule, and it does not carry any charge. So it has 0 charge on it, but H2O, it has -2 charge on this oxygen, because there are 2 hydrogen, each of them will have +1 charge. So that +2 charge for 2 hydrogen and -2 charge for 1 oxygen. So that +2 and -2 cancelled out, and the whole compound does not have any charge. So oxygen also does not have here, is not carrying any charge, so it is 0. In this case, from -1, it is going to -2, and also it is going to be 0. From -1 to go to -2, it has to take one more electron, right? Only then it will become -2 charge. So if if it is taking one more electron, that means it is reducing, is gaining one electron. So this oxygen here, for this case, the first one, the product, is gaining. That means reduction is happening. But for the second product, that is oxygen gas, This is it is losing that one electron it has and becoming 0. So that means oxidation is happening here. So both reduction and oxidation both are happening here in this case. Okay. Okay, so up question 1. A2, why the product but not sulfur dioxide, sulfate? Why the answer is sulfur dioxide? Question 1, A2. Okay, let me go there. Question 1, A2. A2 reduction sulfur. Oh, okay. You're talking about it, that why it is sulfur, it should be S, okay? Why this is sulfur dioxide, not sulfur tetroxide? Sulfur dioxide can stay as a gas. Sulfur tetroxide cannot stay as symbol because sulfur tetroxide will always carry 2 charges. When we start, we study about the structure and the compound formation, then only we know, but now it will be, just remember the sulfur tetroxide, SO4, 2 positive negative charge cannot be, SO4 cannot be staying alone, right? But sulfur dioxide can stay alone, right? So sulfur dioxide can be a gas in a gaseous form. Sulfur tetroxide cannot. Okay, so any other question? Anyone else? Is there any skill or technique to write the half equation? Yes, there are some rules, right? We discussed in the lecture slide. So please go and refer to the lecture slide that you have to balance all the elements except hydrogen, oxygen, and electron. At the beginning, the first step, you balance all the other elements except these 3, hydrogen, oxygen, and electrons. Oxygen you balanced by using by making it a water molecule, okay? By making it a water molecule at the product site, or if it is an excess hydrogen or oxygen produced, then add some water in the reactant site. And for electrons, we have to balance the electron based on the total number of electrons in the product site and in the reactant site. So there are some rules to do so, and okay, let me check if there is any here. Hold on, let me check. In this tutorial, we have a half reaction, I think. Okay, there is a half reaction in question number 3, hair bleach. So I'm going to talk about it soon, and let's see how we understand it or not. Another question is nickel plus H2SO4 sulfuric acid equals to nickel sulfate plus hydrogen. To the product part, why not equal to hydrogen? Why is H2O? Okay, let me check what we are talking about. This is okay, at the end the product is happening. What is happening is nickel, then sulfuric acid, okay, and 2 hydrogen ion here and 2 electrons on this side. Yeah, who is that? Okay, and then it becomes sulfur dioxide gas and water and nickel ion positive. My God, I hope that you can follow. Plus nickel ion, okay, plus 2. Okay, so your question is why it is nickel positive. Let me check. Why is H2O? Why not equal to hydrogen ion? Hydrogen cannot be ion, right? When we write the half reaction, we show the in ionic form, all right? But when we write the full equation, it should be in the non-ionic form. You cannot just leave it in the ionic form, because in the real life, they do not stay alone or stay in ionic form. They will, of course, they will mix together or team up together with the opposite charge and become neutral, because positive charge, whenever there is a charge, it will be very energetic. They are very energetic. So that's why they need to, in a, what do you call it, in a neutral form. So in the A2, the product part, why not equal to hydrogen? Okay, I know that. Why you are saying that why not hydrogen gas, but hydrogen, water molecule, is that? If I just make it hydrogen gas, I could, but what would happen to the oxygen then? Oxygen will be just oxygen gas, is it? You are saying that oxygen gas, but in that case, if it is oxygen gas and hydrogen gas, but it is very alluring, or it is very tempting to just produce hydrogen and oxygen gas, but actually the hydrogen and oxygen gas, they will, their potential energy is higher, so they would prefer to stay in the water as in a form of water, right? Okay, so this is just, to simplify the thing. Actually is not this simple, it's a bit complicated, but the simplifying it, that they will, water is much more stable than the hydrogen and oxygen. They stay in a gaseous form. So all the molecules, or everyone, our human also, we want to be more stable, right? We want to be in stable form. So they also want to stable form. That's why the water will be formed rather than hydrogen and oxygen. But when sometimes if we see that there is no oxygen to balance up, or hydrogen to balance up, so in that case we may leave it as a hydrogen and oxygen gas. Okay, now, and Megan, thank you very much for, this is follow the rule of balance in half equation. But I'm going to give you the here the example that is given in question number 3. Let me go to the question number 3. So it says that write a balanced, anyone, anything? You can just unmute yourself and ask the question if you have any. I'm not looking at the chat room now. So write a balanced half equation for oxidation of hydrogen peroxide to oxygen. So hydrogen peroxide to oxygen. Now you see that hydrogen peroxide to oxygen, right? So it is producing, just keep some room if I need to add anything here later on. Hydrogen peroxide to, it is producing oxygen. It's saying that it is producing oxygen. It's already given us. It's already telling me that it's producing oxygen. So I don't have to think much that water or oxygen, just oxygen. And then since oxygen, I will have hydrogen as well. The hydrogen is coming from here. I will have hydrogen as well from this side. And after this, there will be, we need to balance up this equation. So there are two oxygen in this side, there are two hydrogens. So I have to have two hydrogen in this side, and it should be positively charged, two positive charge. So since there are two positive charge already produced for this, right? Because why I'm producing here not water but oxygen, because is the question or the problem asked me that the oxygen is being produced, right? So oxygen produced in O2, and there are two O here, so it is perfectly fitting in this scenario. So I don't need to add or change any stoichiometric ratio here. I can just put this oxygen here. And then there are the two hydrogen that's left on the left side or on the reactant side. I bring this to product side as a two hydrogen ion, because this is producing as an ion, it's not gas. Okay, you cannot just make it that okay, it's hydrogen gas as well. No, it's not that simple once again. So better to produce this hydrogen ion, and to produce in this process, produce two hydrogen ion. How does this hydrogen ion produce? Because each of them has to release electron, one electron. So there are two electron that is released from there. So now I see that almost my half reaction for this is balanced from both sides. I'm left with this manganate ion, okay, MnO4, manganate ion, MnO4, MnO4, and there are one negative charge. So it will be producing manganese, okay, it will be producing manganese ion, and manganese ion is two positive charge. So if it is manganese ion, I have four oxygen. I have four oxygen here, right? I have four oxygen here. Four oxygen can produce four water molecule. So I will balance this oxygen as per the rule. I mean, it will be easier or much faster to learn to adhere to the rules than going into the reason. If you want to go into the deep, you can, but it will take some more time, more research, more knowledge about the chemical property. So the rule is, I will since there is oxygen, I will balance it up as a water molecule. So 4 oxygen can produce 4 water molecule, and then 4 water molecule will need 8 hydrogen, sorry. So I will add 8 hydrogen on this side. Otherwise, where the hydrogen is coming, right? It is not coming from the air. I have to add it, or I have to provide it. I added it for 8 hydrogen, so that now it is balanced. It's perfectly balanced. You see, 1 manganese, 4 oxygen, and 4 oxygen atoms, 8 hydrogen atoms or ions. There are 4 times 2, 8 hydrogen as well. But the problem is, sorry, but the problem is, am I balanced with this electron number? Is it? Because here is one negative charge, let's say one negative charge here. 8 hydrogen is 8 hydrogen positive, 8 electrons, sorry. 8 electrons, positive charge here, positive 2 here, and here is 0. Can you give me 1 minute, please? Okay, I'm back. Sorry, yeah, I had to take that call. Now, where I was? Okay, so here altogether we see that the deficiency of the electrons, okay, is on this side is 2 electron, right? So these 2 electrons are here, and then sorry, what should I do now? Okay. Okay, sorry. Now here you see that this is the -1 charge, right? This is this arrow on, or maybe we can consider it is an equal sign. So if I bring this negative charge to this side, it will be positive charge, right? Or vice versa. If I bring this positive 2 on this left side, it will be -2. So the rest, I mean, this is altogether is 3 positive charge, right? 3 positive charge. And then from 8, if we bring this positive 3 to this side, it will be positive 5. The leftover will be, or the balance is positive 5. It will be positive 5. Becomes messy. Okay, let me delete it first. Oh, cannot delete. Okay, so this is the way that we can balance the electrons. Electron balance is important, and most of the time students make the mistake of balancing the electron. They, I mean, just leave it like that. You will not get the marks if you just leave it. Or there are marks, okay, on balancing on everything, balancing of the elements, balancing of the water, I mean, hydrogen and oxygen, and electrons as well. So, yeah. So now I know that it is positive, -1 charge, here is positive 8 charge, and here is positive 2 charge. So that, and it is on the other end of the equal sign. So from the arithmetic, we know that if we bring this positive charge from left side to right side, the sign will be changed, right? The sign will be changed. So I bring this positive 2 to this side, it will be -2, and we add it up, it will, the balance is positive 5. The balance is positive 5 on this side, on the reactant side. That means I need more 5 electrons, 5 more electrons on this reactant side to balance the whole number of electrons. And now you see that it is balanced. Now you see that this half reaction, for this it is balanced. This is also balanced on the, this one is also oxidation and reduction, both are balanced. So now another thing, the problem is I have where these 5 electrons are coming from. It is not coming from nothing. Nothing, I mean, something cannot come out of nothing, right? So this electron cannot come out of nothing. This 8 hydrogen ion or proton cannot come out of nothing. I have to have this in the system, only then it will be. So these are things are coming out from this side. These are the things that is coming out from this side. So if we want to have 5 electrons, how can I have 5 electrons? Because I am having 2 electrons here. How do I find 5 electrons here? From there, how can I make 5 electrons out? I mean, so the stoichiometric balance will be if I multiply here by 5, and if I multiply this side by 2, right? So that it is 10 electrons on this side, and 5 times 10, 2 is 10 electrons on this side as well. So this, so now it is balanced. And we see that 5 times 2 hydrogen is 10 hydrogen ions, and 8 times 2 is 18, right? So there is one thing that is I have to have another something that is missing. Okay, let me write it actually. All right, so here I multiply, okay, I multiply this with 5 and multiply this one with 2. This is number 1 reaction, this is number 2 reaction. Okay, so I multiply 1 with 5, multiply 2 with 2, and then I have 10 electron and 10 hydrogen here. So the overall reaction is becoming H2O2, and this is I'm adding up, so that a MNO positive, negative charge of 4, and there are 10 electrons on the both sides, so that we can just cancel it, because this 10 electrons on the right side of the equal sign, that means on the arrow sign or product side, and these 10 electrons on the left side or on the reductant side. So that's 10 electrons are cancelled out, because if I bring this here, it will be negative 10, so that we can just cancel out this one. And what is left? Okay, so 10 hydrogen here, 10 hydrogen here, and then here is 8 times 2, 16 hydrogen here. So altogether is 6 hydrogen left after subtracting on the both side. 6 hydrogen is left. And on the right side, I will have O2 from there, from this O2, from here I find, and also Mn2 positive charge, and 4 water. Okay, not 4 water, sorry. Yeah, I already multiplied it with 2, right? So there will be 2 magnesium as well, sorry. And 8 waters also. 8 waters. Oh, and the first one I multiplied by 5, so it should be 5 here, sorry, and 5 oxygen, because I multiplied with 5. So this is how, and I multiplied this one too, so 2 magnesium. So this is how it is coming. This 5 hydrogen peroxide, 2 magnesium tetroxide is reacting and producing this. Is it okay now? Or you want me to go over again? Anyone? Thank you. Anyone has any question? If not, then I'll just take the attendance. I'll take the attendance. Okay. So since no question, okay. Since no question, I'll take the attendance now. Mohammad Anis. Chiang Wei Tio.
Yes, sir.
Thank you. Carlot.
Yes, sir.
Nishi.
Yes, sir.
Rizbi. Rizbi.
Yes, sir. Present.
Hao Liangsun.
Yes, teacher.
Gwenda.
Yes, sir.
Tammy.
Yes, sir.
Yu Chen Chung. Yu Chen Chung. Okay.
Here.
Kelvin.
Here.
Intimacia. Intimacia. Intimacia and Tambu. Okay, absent. Eman.
Here.
Sophia.
Here.
Marjan. Marjan Nafi. Marjan Nafi, absent. Veron.
Here.
Jia Keki.
Yes, I'm here.
Thank you. Bernice.
Here.
Chen Lianpio.
Yeah.
Chen. Okay. Megan.
Here.
Jia Weissen.
Here.
Angel.
Here.
Darren Kwang.
Here.
Jun Hyun Chia.
Yeah.
Brandon.
Here.
Here.
Oh, both Brandon are here. Okay. And then Adelaide.
Yeah.
Sagar Shankar Roy.
Here.
Lian Sonti.
Here.
Brian.
Yes, sir.
Darren John.
Yes, sir.
Siu Siang Liu.
Yeah.
Jason.
Yes.
Lik Sen Tan.
Here.
Jonathan.
Yes.
Gabriel.
Here.
Taniera Zua.
I'm here, sir.
Chuin Chiet Sim.
Here.
Che Wen Kong.
Here.
Chun Hui Chan.
Here.
Good, very good. Okay, so once again, Marjan Nafi. Intimation Tambu. Okay. Anyone here from group 1? Practical group 1. Lab group 1. Is there anyone?
Me, sir.
Who is that?
Darren John.
Okay. All right. So is there any question? Is there any other question anyone has? Okay, so see you. Thank you. Bye-bye. Take care. And on next Monday, I will have the lecture class. And after that, on Monday, Tuesday, I will have the lab.